All right, this is a classic second law problem involving forces and something moving. And in this case, we always want to start by drawing a force diagram. So we're going to try to sketch this out. So we have a wagon. So we'll start by drawing a wagon. Assume it's sitting on the ground. So we'll just sketch that. And we want to draw every force that is acting on it. So first we're going to start with the forces that are specifically stated. So it says it's being pulled to the right with a force of 50 newtons. So we can start, draw an arrow to the right of 50 newtons. So that covers the 50 newtons. Now friction exerts 10 newtons on it. So you have to ask yourself, what direction is friction going to pull this wagon? And friction always acts against the direction of motion. So if this wagon is going to be pulled right, friction is going to act to the left. I'm going to draw a slightly smaller arrow because it's a smaller force. So there's 10 newtons to the left. Now, I should also note, it's not going to actually affect the problem, but gravity, if there's gravity involved, there's always a force of weight. And so we're going to just put this in here so for future problems we're comfortable with that. So if this wagon has a mass of 10 kilograms, that means there is a force of weight pulling this wagon down. And we can always find our weight using the equation, weight equals mass times the acceleration of gravity. So that means our mass is 10 kilograms times our acceleration from gravity. We're just going to use the simplified 10 meters per second squared. So the weight on the wagon is 100 newtons. So that means there is a force of 100 newtons pulling this wagon into the ground. But we know this wagon is not going to be pulled downward. So there must be some other force canceling this out. And that force is actually exerted by the ground on the wagon. It's called the normal force. And it is also 100 newtons because it keeps the wagon from sinking into the ground or taking off into the air. So it's not more than 100, but it's not less than 100. So those two are balanced forces, so they're going to pretty much cancel each other out, and they're not going to really affect this problem. What we're really looking for is what is the net force. So if there's 50 newtons to the right and 10 newtons to the left, the net force, what we'll call F net, is going to equal 40 newtons. So that means that overall, the force is 40 newtons to the right. So that's our force. And we have our second law, which states that force equals mass times acceleration. And we just found the force. We know the mass. We're looking for the acceleration. So A is going to equal F divided by M. And F is 40 newtons. And M we just found was 10 kilograms. So the acceleration of this wagon is 4, and it's meters per second squared. The units, that's what it'll end up being. A newton is actually equal to a kilogram times a meter per second squared. This is another way of describing a newton. So the units end up canceling to give us meters per second squared. You shouldn't have to worry about that as long as you're using common units. So anyway, that's how we do a force diagram second law problem.